Okay, this is section 3.7, and this is the modeling, introducing to modeling. Um, and so modeling is a way of taking data that's given to you of a real life situation and creating an equation and see that it allows you to make short predictions. Um, One thing that they talk about in the book is this study tip. And so let me read that to you. There is often more than one way to accurately model data, so don't be afraid to try methods. Part of the modeling process is trying to justify the reasoning behind a particular modeling choice. So some people, like some students I know of, get frustrated when their way of approaching something is different from someone else's, but yet they still see that they're getting the same answers. And so that's something that is nice about math, is that there's more than one way to get to the answer. And so looking at other students' work and seeing that is very helpful. So if you take a look at the next page, we take a look at two graphs. Here's the first graph that's doesn't have any line, does not have a line drawn through it yet. But you can see that the points are increasing in a kind of a linear fashion. Not quite perfect, but it is pretty much taking on the characteristic of a linear line. And so that's what they did here in the next graph here, is they took the same points and drew a line of best fit. Notice it looks like it's pretty much touching all the points, but it's not going through all the points. And so that's something that we have to do sometimes. We have to draw a line of best fit and then use just the line to help us do predictions. So in essence, once you draw your line, you cannot use the points that are not directly on the line. You must pick points that are on the line itself. And so that's something that is misunderstood a lot, is that students will pick the points even though the points are not even on the line or they're slightly touching it. But it should be picking points that are directly on the line or picking your own points that are on the line. That really makes sense. So again, here is two more graphs. This one's an exact because all of the points land on the line. So we call that an exact linear model. But then we do what's called an approximate linear model, where you're drawing your best line, but notice that the points are not on the line. But notice when they do draw a line, they have 1, 2, 3 points below the line and 1, 2, 3 above the line. So that's kind of the way you want to do it, is that when you draw a line of best fit, you draw the line so that you have the same kind of setup, where you have the same number of points above the line as well as below the line to make your best line. And that's something that students don't always do. They don't count their points and see that, oh, I've got 20 down below and only 1 above. And so that's telling me that you didn't really draw that good of a line. So you should draw it in such a way that you have the same balance between the top and the bottom of your line having the same number of points, pretty close anyway. So let's take a look at example 1. They give you a table and they're asking you, does the equation 2x minus 4006 model the data exactly? So we could have created our own equation from the points. We could have graphed the points and then drawn a line of best fit, and we probably would have come up with something close to this equation. We probably wouldn't get exactly. But anyways, does this equation model this? Well, if you look down below in the example, we see that 2009, when we put it in, gives us a 12. And when the table, we're supposed to get a 13. So far it's not working that perfectly anyways. If we do 2011, 2013, and 2015, they do match. But the only one that doesn't match is the first one. So this is not an exact equation, but it's pretty darn close. It's pretty darn close. So that's something to take into consideration on that. So if we take a look at another one, they're suggesting us to do exercise 13. Let's do that one together. So 13 is actually on page 243. So they're saying that for problem 13, oops, let me go clear that. Okay, so here is 13. I still keep having issues. Sorry about that. So 13, and the table they're giving us is x and y, and we have 0, 1, 2 for the x, and then for the y it's 2, 4, and 6. And they're saying, does this equation y equal to 2x plus 2 match this data perfectly? So I'm going to go ahead and put in each of the x values. So y equal to 2 times 0 plus 2, which gives me 2. So that worked. And then y equal to 2 times 1 plus 2 gives me 4. So that one worked. And y equal to 2 times 2 plus 2 equal to 6. And that one worked. So in this case, this particular equation models the data exactly. Does exactly. So let's do another one. Let's do 18 because it has fractions in it, and I know students really are frustrated with fractions when they do that. So it's always nice to get them in there because that's typically what we see later on when we get into higher math, is that we have to remember stuff that we have learned in the past. So this is -7, -1, and -1. I'm sorry, -4, -1. And then we have 5, 1, and -3. And so the equation that they are wanting it to match is y equal to -4/3 x minus 13 halves, or 13/3, sorry. So let's put in the x. So y is equal to -4/3 times -7 over 1 minus 13/3. Okay, and so we multiply, we get a negative times negative, which is 28 minus 13, and that's all over 3. And so 28 minus 13 is basically 25, I believe. So that's 25. Okay, so just checking. Okay, and then y equal to -4/3 times -4 over 1 minus 13 halves. Right? And so we get 16 minus 13 over 3. And so 16 minus 13 is 13/3. And then we get y equal to -4/3 times -1 minus 13/3. So that gives me 4 minus 13, which is over 3. And so that gives me 9 over 3. Oops, daisy. Yep, and that's negative. Okay, and so I get -3. So let's recheck our math, make sure that we didn't make any mistakes, because 4 times 7 is 28. It's positive. So 28 minus the 13 is 15. So I did that wrong. So that's 15. And so now 15 divided by 3 is 5. So that's checking with this. And then let's see what I do here. This is 16 positive times, that's 16, and 16 minus 13. Oh man, I made another mistake. That's actually 3, isn't it? So that gives me 1. So that checks off here. And then I get a -3. So this equation does exactly match the data that we have here. And I caught my little mistakes here. So when I am thinking, oh, it's not going to match, I kind of want to double check my math, because sometimes I overlook something. I'm thinking too simple or something. But yeah, 28 minus 13 was 15 and not 25. So anyways, here's another example of how the actual equation does match the world situation data that we're looking at.